All right, now that we know the terms about the resonant frequency, and we know that every circuit is going to be consisting of R, L, and C. Well, right here in this circuit, I have R, I have an L, and I have a C. Right here is inductance, and right there is capacitance. And so what we're being asked to find is the resonant frequency, right? And I said this is FR for resonance, or it could be called FS for series resonance, or remember the special frequency where the current is maximized. We're going to find the resonant frequency. We're going to find the quality factor. We're going to find the bandwidth. And then we're going to find the I that is going through the circuit when we're at resonance, which should be the maximum right here on this chart, right? So we're going to find the parts of this graph that are always true. So the FS, the resonant frequency, I can just plug in the formula. I said everything you need is on the equation sheet. Fs right here, 2 pi, the square root of LC. Here's 2 pi, there's the square root. L is equal to 320 micro. C is equal to 800 nano. So whenever I'm typing that in the calculator, I do E -6 and nano is E -9. And the FS that I come out with is 9.947 kilohertz. If you're using the lecture notes and you didn't just copy down this circuit, but you are using it on the page, there may already be some answers there. They're not as precise as what I'm doing, but you can still copy your own to make sure that you understand how you would grab these. All right, so then the quality factor, if I'm looking back at my equation sheet, I said the quality factor here is X over R, omega, L over R. Well, which ones of these do I know in order to solve for this? I'm not a fan of the plug and play, but this is a case where oftentimes we can just look at which formulas we know and which ones we don't and solve for it. So in this case, I'm going to go with X over R. I don't know X yet, but I can easily get it now that I have the frequency. So if XL is equal to 2 pi FL, 2 pi, that resonant frequency is 9.947 kilohertz, and the L is 320 microhenries, then my X of L comes out to 20 ohms. So I plug that in, 20 ohms. And if you wanted to plug in the kilohertz into 1 over 2 pi FC, you would also get 20, because that is what resonant frequency, it's what happens at the resonant frequency. XL and XC equal each other. The R inside of the series circuit is 1, and so my quality factor is equal to 20. It's unitless. It's ohms over ohms if you want to look at that, right? So the ohms cancel out, and it's telling me how narrow my bandwidth is. What is the bandwidth? Once again, I see which terms I know. In this one, I know the resonant frequency, and I know the quality factor. So I divide 9.947 kilohertz over the unitless 20, and I get 497.36 hertz. If I'm looking at these cutoffs, and I don't plot the current and label F1, F2, and FR. So right here, F1 is equal to the Fs minus the bandwidth over 2. So 9.947 kilohertz minus 497.36 divided by 2, and it comes out to F1 equals 9.698 kilohertz. This F2 on this side, F2 is equal to the 9.947 kilohertz plus, because it's higher than the resonant frequency. So I add that 497 over 2, and I come out to 10.195 kilohertz. So if I'm looking at this graph here, I'll pull this down so that we can see, right? And so if I was to label these, I would put on the F1, 9.7 kilohertz. Right there, the resonant is 9.947 kilohertz, and the F2 is 10.2 kilohertz. That's with rounding. So now we've labeled the bottom of the graph, and we have this bandwidth here that we can see of 497 going from here to here. And it's saying that if I choose any of these frequencies within this range, I'm going to get over 70% of the current. Well, 70% of what current? Let's find this I in this circuit now. So if I'm looking at favorite law, still holds true, V equals IZ, and I have a series circuit, right? I'm going to find the I, I'll say the total is the V total over the Z total. The V total is given, 10 volts, angle 0 on that source. And now the Z total is going to be my 1 ohm. And then if I said that this X sub C was 20 ohms, well, at the resonant frequency, I have plus 20J, but I also have minus 20J for the X sub C and the X sub L. Right here, XL, right here, XC. Those equal each other, so that makes sense that it would just be 10 angle 0 over 1 ohm. And what I get is 10 amps angle 0 degrees. So right here is the 10 amps. And then right there, if I wanted to label that, instead of writing it as 0.707 times Imax, I could just write 7.07 amps. So I get a lot of current, even if I don't quick choose right at the resonant frequency. But everything within here is within the bandwidth.